Okay, our last two theorems deal with kites. Now, theorem 6.26 says that if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Now, those angles that are congruent are the intersections of the two sides that are not the same. So in this case, J and L. So you have to make sure that you pick the two sides that aren't congruent. Notice that the bottom two pieces, JM and LM, have 2 marks on them, and JK and LK have 1 mark on them. So these two angles, J and L, are congruent. Okay, let me get rid of this, and let's look at our problem. Okay, if WXYZ is a kite, find the measure of angle XYZ. Let's first mark that angle. Remember, in the 3-letter name for angles, that Y is the vertex of the angle. So XYZ is at Y. So I'm looking for like what would be the bottom of the kite if this thing was rotated 90 degrees. Okay, now the two sides that are not the same meet at the angles that are congruent. So WX and YX meet at X, and that's 121. That makes the angle right below it at Z 121 degrees. Now, what do we know about all quadrilaterals and all of the angles? All of the angles in a quadrilateral add up to 360. So in this case then, 121 plus 121, that's our two congruent angles, plus that 73 degrees at angle W, plus some other angle. We'll call this angle X there. Well, let's rename that angle Y. So whatever angle Y is, adds up to 360 degrees. 121 and 121 is 242. 242 plus 73 is 315 degrees. So 315 plus whatever angle Y is should give me 360. So I just need to solve for angle Y by subtracting 315 on both sides. That cancels out. Angle Y is equal to 45 degrees.